Yeah, this is my next. Do you remember this
From
from
the old days at Alma Days.
That's right. And I sell them now, and no one buys them. I get like one order every 8 months. But he says that it's because this is actually a confrontation, and that works when I'm in trouble. But it doesn't work. It's interesting. I mean, by the way, that's another thing that was true of a lot of my often I am. So welcome to Talks. This is our forum that happens on Tuesdays when class is in session. And thank you, everyone. I know that this is the end of a break, so maybe it isn't in session. We have it online on Adobe Connect. And of course, any of you that know people that want to be invited, this is an open forum. And we have people from the area mostly coming to it. We've had, as you know, exciting speakers like this new embedded the microprocessor. But we have somebody almost that exciting today. Terry is a very prominent figure in many fields, and you guys from his abstract know about his work in AI, linguistics, and HCI. But what he always puts up is the fact that he's a grandfather. So here's a whistle that he's for your child. And earlier,
If you don't give little kids whistles,
I give their grandparents.
parents will shoot me.
And you were pointing out that my bookmark was inappropriate for 2000. So I've given you a brush for your keyboard, which is also out of date. What people, it's a brush for cleaning your keyboard. You seem to have one over there instead of a tablet. So there it is, a brush. And what's interesting is I've done kind of parallel play with Terry since a long time ago, since when I started hanging out as a graduate student when he was already a professor at Sale. But what you guys don't know about him is how his students feel about him. And I wasn't one of his students, but his students find him to be the most remarkable mentor and intellectual leader. And as a teacher, he's renowned. And so we're lucky today to get a little bit of that. And what I want to tell you before we start is just that if you want to ask a question, get my attention so that I'll throw this to you. Now you just speak into it.
Hello.
So you'll just speak into this, and you can hear that it works. And that's the way that we can tell who's going to ask a question. Also, it's a way of getting an audio record of what's going on here. At one kind of, I guess it's 2:25 or something, we'll move out into the hallway so people can mingle. And hopefully Terry can stay for a little bit and talk to people. And so thanks for everybody for coming in.
Okay. It reminds me, I don't know if any of you have been to the Pickle Family Circus. They have this thing where they pass around the audience this huge beach ball. I mean, it's probably about 6 foot diameter. And everybody's doing this and tossing it. And at one point, somebody's got a pin and it's full of confetti. Right? And so I'm waiting for that to explode in confetti.
Your voice will be the confetti.
So thank you, Ted. It's very nice to be here. I've been over here at CMU West a couple of times and enjoyed the interaction. And certainly enjoyed a wide variety of interactions with Ted over the years. I have a seminar series a lot of you probably know about on Fridays at Stanford. And he has spoken, I think, more than 7 times, is it? More times than any other one speaker. And that's spread out over 20 years. Right? So it's a good history. So what I'm doing today is a kind of retrospective reflection. It was putting together this set of slides was originally motivated when I got a lifetime research award at CHI a couple of years ago. And it gave me an opportunity to sort of take the very broad view, both on the field as a whole and on my participation in it over the years. I like the fact I see both a bunch of gray hairs here who will actually be able to answer questions on who was that, and new students. So you can get a sense of the history of where things have been and where they're going. And I'm going to put that history in a particular framework, which is what my title implies, which is CHI, for example, the conference that we all go to, stands for, obviously, computer-human interaction. Notice that often the field is referred to as HCI, put people first, not the computers first, which is a good idea. And I'm going to focus on how we think about humans. H is human. What does that mean? What does it mean to interact with a human for a computer? So that's going to be the sort of thread, and talk about how the field has evolved over the years and how it has interacted with lots of other fields that are related. So, start with a computer. All right, I'm going to give a very brief history of computers that people interact with. What is this? Some of you should know because they've got one down. Down the street here in the computer museum, right? This is not Babbage, as you may surmise. This is actually Jaron Swade from the Computer Museum in London, where they have a working model of it. And if you get a chance to see there, I don't know if the working model over here is open all the time, but this is a difference engine, not the analytic engine. But computers as something that you can use and interact with go back at least a couple hundred years to 150, whatever it is, to Babbage. Jumping ahead a century or so, or not quite, this is an early computer interaction. Who's this? Grace Murray Hopper, who was one of the very first people to program and design programming languages. She was an admiral in the Navy. This is a Navy machine. This is a UNIVAC. And in those days, what it meant to interact with the machine was sort of like a personal computer, right? You sit in front of it and you push the buttons and turn the dials, and it does stuff, right? So in the early days, the very early days of computing, it was very interactive in that sense. This is a computer. Who's that? That's me. That was my high school science project. This is now in the early 60s. This was actually a combined analog digital. It was digital because these had these position switches that were stepped, but it was analog because what it did is feed resistor banks and you turn dials and helipots up here. How many people have ever used a helical potentiometer? Called a helipot. Anyway, what was interesting about this is I went to the science fair. I thought it was cool. I built it, and it did a very simple calculation. If you fed in basically 4 parameters, which were points on a graph, it fit a quadratic equation to those 4 points. And it turns out that Newton figured out how to do that. It's not a very hard equation, but it was built in. The response from the people at the science fair was, hey, that looks really interesting, but that's not science, that's engineering. And that's something that our field has sort of struggled with all these years. We call it computer science, but it really bears more relationship to all the engineering fields than it does to the classical sciences, physics and chemistry and so on. So from an early point, I was sort of in the computer science / engineering business. Here's what big real computers looked like around that time. Mainframes, reel-to-reel tape drives. You had these big rooms with the glass and the air conditioning and people in white coats, or at least white shirts and ties, who, I guess he has a white coat as well, to take care of them in the way that you programmed, the way that people other than the priests of that did is you. How many of you have ever used these? Okay. Yeah, right. About half you can divide by age here, right? If you're under the age of what, about 30 or something, you didn't have to use punch cards. When I first started teaching at Stanford, the introductory programming course, which was in Algol W, where W stood for Wirt, Nicholas Wirt, and that it was the ancestor of Pascal. And students punched decks of cards and took them to the computer center and waited for the printouts and all that kind of stuff. Paper tape was a little easier to use in some ways and more on smaller devices. My first computing, beyond the little thing I built, was with paper tape. It was with this device. Okay, now real history. Tell me what this is what it looks like in terms of size. This is like a desk, like a regular office desk. You put your knees in under here and so on. Anybody know what company made that? Control Data 160. Okay, so when they were busy coming up with the biggest supercomputers, this is the very early days of Control Data, they were also developing what we would now call a desktop or a personal computer, right? I mean, it wasn't a desktop, it was a desk. Had 12-bit memory, 12-bit address space. Quick calculation, you can tell how many bits, total bits of memory, not very much. And the input and output was paper tape, which you saw a picture of a minute ago, which goes through this reader. And then over here on this side, there was a slot that barfed out paper tape. So it was all paper tape in, paper tape out, and console with Nixie tubes and buttons. Okay, so what happened is my own history, this is my first real computer that I used. So I started my career using a personal computer, right? This is now 40-some years ago. There was a doctor at a local hospital who had just moved there from a bigger city. I was in Colorado Springs, Colorado. And they called up and he had a grant from the health, NIH, I assume NIH, to do calculations of radio therapy dosage for cancers. So basically, the simple idea, if you're going to put radiation to a cancer, you don't want to just aim at it, because everything between the cancer and the outside gets even more radiation. So you cut across. You put in a beam here, a beam here, a beam here, and that way the cancer gets a high dose, everything else gets a low dose, and of course you have to calculate how that should all work. So he had gotten a computer to do that, but then he ended up moving to a small town, and he said, called the college up and said, do you have any students there who know about computers? Of course, they said, about what? What's a computer? He said, well, how about just a math student who's good at things? So I was a math student. And so basically, I was the programmer for this computer. I sat in a back room at the hospital, and whenever I went and used it, it was being used. And I learned how to do things like print out banners on the paper tape, and what everybody will do when they get to compute, which is have fun with it. And also develop programs. I didn't know anything about programming or programming languages. I had no training whatsoever. So I actually programmed in machine code by pushing the console buttons. I later learned about assemblers and things like that. I did have the machine manual, at least that the instructions did. So I was my own assembler. The repair person used to say, I don't know why your machine always has much more problem with these buttons than everybody else. Right? Because he didn't realize I was doing all my input that way. So this is now 60s. And at about that time, a little later, there was a new kind of interaction. Who's this? Somebody knows him. Joe Weizenbaum at MIT. This is a Model 35 teletype. And that's the era in which people like John McCarthy and others came up with the idea of time sharing. So the way you interact with the computer was not either have your own computer or punch a deck of cards, but to have a terminal. And you could type at the terminal, and it would react back to you. I'm not going to try to give a lesson on what time sharing is and all that. If you don't know that, you should go back and read your history. And I'll talk about Joe's program a little later. Jumping ahead, notice this is a quick tour. Somebody knows what this is. The Alto, right? So the Xerox PARC Altos. This is Xerox PARC is where I first started hanging around with things Ted was involved with. And this really changed the game, as everybody who's followed the field knows, which is giving the idea that what's on the screen should be visual, not just a set of characters, and that your interaction with it should be tangible, like moving a mouse, not just typing on a keyboard. What's striking, really, is how little different most of today's systems are. I mean, until we started moving to tablets and phones and stuff, as long as you stay on the desktop systems, really were the course was set back in the early 80s by Xerox PARC and then Xerox Star, which followed it. I mean, one of the interesting things of doing this review was sort of realizing how much of what we use really has been around a long time and hasn't changed that much. This is from about the same era. Somebody certainly knows this is. God. Doug Engelbart, right? So Doug Engelbart was working on systems he was at what was called, at the time was called Stanford Research Institute, now called SRI. And he had a very different idea about computing. And this God moniker is not out of keeping, really, for what he did to shift the way people think about computing, which is up until then, everybody primarily, and obviously these things always have details, was thinking about, I get a job done on a computer. I type it in, it gives me results, I get it done. Right? Or it was a real-time system for some big job like air defense or something. He said, I'm going to make it possible for people to work together. That's always been his main theme, people working together. And this is a grocery list, right? So he was thinking about computers not as doing some fancy scientific calculation, but as being a part of supporting your everyday life. And doing it in a way that connected you with other people who were using the same computer, or the same network, of course, if that expanded out. This picture is from an event which is often referred to as the mother of all demos, which was this amazing tour de force. This was back in '67, I believe. I'm sure there are videos of it. Again, you go to the Computer Museum, you can learn all about it. But in addition to demonstrating this system, which was completely innovative for the time, they did it with video conferencing. So he was actually in San Francisco at Brooks Hall, and Jeff Rulifson was in Palo Alto or in Menlo Park at SRI, and they were on each other's screen and talking back and forth. They had projection. This was in a big auditorium, was being projected up onto the screen. Today, projector is like, everybody has one, not an issue. Those days, it was incredible technological wow to be able to project from a computer up onto a screen. And it was this thing called a Rubicon, which used oil and electrostatics and all sorts of weird stuff just to get a picture up on the screen. So he did a really amazing job. And I'll talk a little more later about the philosophy behind it. Moving back to Xerox PARC, as we tend to do many times. If you can see sort of light here. This guy? Yeah, Mark Weiser. You can tell by the suspenders. He always wears suspenders. Mark Weiser came up with this idea that he called ubiquitous computing. And one of their slogans was, you should have computing by the inch, the foot, and the yard. So computing by the inch was this thing called PARC Tab, which is eerily prescient about what our computing looks like today. The PARC Pad, which was a lot like, I won't say it's a lot like an iPad. Obviously, it was extremely primitive and crude and so on, but similar in the sense of what it was trying to do in the ecology of an office where you had one on your lap while you were looking at the yard size display, the PARC board, live board, right, which Ted worked on, and the idea was computing was part of an environment. Okay, it was part of, their idea was actually you wouldn't even own these things. These are tabs here. They'd just be sitting around on the table, and you'd pick one up and use it and put it back when you needed it. All right, it was such a fluid part of the environment. This is a project we did at Stanford called the iRoom, picking up on that, where we had large, high-resolution displays, tabletop displays, integrated with laptops, integrated with small devices. Okay, that same sort of, it was a sort of a higher tech version of that vision, and that's something which you see in a lot of different forms going forward. How do you integrate, not just how do you have these things separately? This was a particular version, this is Francois Gombetier, who did a very high resolution. This is actually a tile display, so this is actually one projector's worth. Here you can see the lines a little, so you could get thousands of pixels. Nowadays, of course, that's much simpler, but this is 10, 12 years ago. And then doing direct interaction using pen. So I'm going to stop that, and I probably should have, said, I'm not going to show you iPhones and iPads and all that stuff because PARC had those. Now, of course, they didn't really have those, but they had that basic idea, right? That with the way you interact with the computer can mean anything from the thing you turn your punch card decks in to something you carry in your hand. So I'm going to take a second sweep through and look at how people have thought about the people involved in computing. So I'm going to go back a little farther. This is one version of people. I'm not going to go back as far as Leonardo. But if you look at that, when you say, what is the human, it has to do with physical size, proportion, ability. And that was a field that got a lot of attention back in the 1940s, 50s, under the name of human factors. Okay, this is actually a book from Dreyfus, Henry Dreyfus's book on industrial design. And the idea was if you wanted to understand how to build physical things for people to use, you had to match them to human capabilities. They had to match how far someone could reach, how strong they were, what they could do. So one whole direction that actually was pretty much the ancestor of human-computer interaction was this field of human factors. So if you want to say, what is it? It's looking at the physical body. And we still need to do that. What's interesting is that when we design whatever it is, whether it's a phone or whatever, we are very much have to fit the constraints of how big are people's hands and how heavy is something that they can comfortably lift up to use, right? And a lot of the successes and surprising failures in HCI have been because of missing that factor. Right? The Newton is an example. Right? The Newton had a lot of interesting things, but one of the problems was it was too big to be convenient. When Jeff Hawkins was designing the Palm Pilot, he walked around with blocks of wood in his pocket, because he knew that that block of wood had to be a shape and a size and so on that people would feel comfortable carrying. That was one of the things the Palm Pilot did, which of course the Newton didn't, which is to achieve that factor of fitting the human physical factors what works. We're seeing a lot of talk today about Google Glass, right? A lot of human factors in what do people wear on their face and why and how. Physical factors. There are other ones too we'll come to. Okay, you flunk if you don't recognize this guy, especially since I put his name on the board. Alan Turing had a different take on what made something be human. And his take was, as we all know from his Turing test and so on, this is back in 1950. Oh, this font has shifted slightly. That box is supposed to include the 1950. That if you could use language like a person, if you could, in some sense, duplicate what people do when they're interacting in language, then you are a person. The old, if you quack like a duck and waddle like a duck, you are a duck. That was his duck measure, was could you interact in ordinary human ways. That got picked up. Who knows who this is? HAL 9000, right? So if you look at the movie 2001, and for those of you who are young and haven't seen it, you should go see it. It does two things. One is a really interesting view of the whole question of intelligence and so on. The other is it shows you the difference between movie making in the days before all the fast cuts and so on. I mean, incredibly languorous sequences and so on, which is an interesting difference. Anyway, HAL passed the Turing test, right? HAL was the controlling computer on the spaceship and could play chess and have chats and get mad at people or at least try to kill them and so on. I guess he wouldn't say it was mad, he just tried to kill them. So this is a second view of what a person is. Person is somebody who understands and can use language. That was a very influential view. I talked earlier about Joe Weizenbaum. How many of you have played with some version of ELIZA or the Doctor program? And again, yeah, great. I mean, if you haven't, it's worth checking out. I'm sure there are versions of this that run in your browser. Took major programming advances for him to do it back in the 60s. ELIZA was a program that interacted as though it were a doctor, a psychiatrist helping you with your problems. So this is the middle of it. The human says, you are like my father in some ways. ELIZA says, what resemblance do you see? You are not very aggressive, but da-dum-da-dum. What makes you think I am not very aggressive? You don't argue with me. Why do you think I don't argue with you? Okay. You're afraid of me. Does it please you to believe I am afraid of you? Okay. Now, there's a really important lesson from ELIZA, which is why I sort of go into it here, which is it's a really simple program. It's an exercise you could give any elementary programming student and they could do quickly. All it does is look for certain key words and phrases and then rearrange the words. So if it says like, it says what resemblance do you see? So if you said I don't usually like pages on Facebook, it says what resemblance do you see? Right? It doesn't know that you're using like in any given way. It just sees the word like. If you say you are, it comes back with what makes you think I am, and then it just chops out this piece. It's not very aggressive. So if I said, you are here, it would say, what makes you think I am here? Right? It says, you are kidding me, it would say, what makes you think you are kidding me? Right? So the program itself is really simple. And the result was strikingly lifelike. People, there are all sorts of stories of people who, got too personal. They made other people not look over their shoulder because they were having this deep conversation. People who thought it was a real person. Now, Weizenbaum did two things. One is a really clever, dirty trick, which is to pick psychiatry. So if I'm talking to you and I say, my friend's mother came for a visit, and you say, tell me more about your family. I say, wait a minute, I said my friend's mother came for a visit. Eliza doesn't know that. It sees the word mother. It says, tell me more about your family. Right? But a psychiatrist says that. You say, oh, I see. My friend's mother coming is reminding me of my own mother, and why don't I talk about my family? Right? You give them all this credibility, and that's the lesson, which is for whatever the domain is, people will read into their interaction what they think it would be if it were a person. They will make assumptions based on thinking of it as though it were an intelligent person, even when those intelligences are completely not warranted. Right? The other thing he did is he put a lot of just clever, in some sense, psychiatry in it. So if you say, so-and-so is always da-dun, 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 it says, can you think of a specific example? Now, anybody who's sensitive to emotional things knows that when some of us are gone through marriage counseling, that when you say, my wife always da-dun, da-dun, that the psychiatrist knows that you're thinking of some particular event, but you don't want to say it. And just triggering on the word always is enough to get that. So it says one interesting thing is choose your domain well. I chose a different domain. This is Sherdlu, which is the program that I wrote back in the 70s, or late 60s actually, which uses ordinary language. You type in sentences at the top, and it responds with sentences. And the world that it talks about is a simple blocks world. So it's a set of geometric shapes. Notice that was in the era before we had hidden line elimination and good graphics. It also, they're colored. If you look really closely, this says red, it says green, and so on. It's also the era before color graphics, right? But we did what we could. But it had a very, what it did, the previous programs didn't. First of all, it related the language to this specific world that it modeled. So it had a representation of this world. And the idea was that when you said something like pick up a bigger block, it actually could convert that into a operational piece of code relating to this particular scene. And then also had logic. So in fact, it would, if the red block had something on top of it, it knew that it knew is anthropomorphizing. The code got it to move things off of that object before it went to pick it up. Very primitive view of physics, but enough to be realistic for the simple examples. And then it also had built in a number of heuristics about discourse. So if after this I said, now a green one, what does now a green one mean? If I walk up to somebody and say, now a green one, it makes no sense. But if I've just said pick up a big red block, it makes perfect sense, right? Because in the context, it means pick up a green block, right? So what it did is it had some rules for things like one and for leaving out phrases and so on, so that it felt much more like a conversation with a person than what at that time was your typical, even today pretty much, your typical conversation with, let's say even with Siri. You can't say, and now a green one, and expect Siri to connect it up to what you've said before, right? Again, people read a lot into it. Right? It was a very simple, it had a 200-word vocabulary. It didn't have any real concepts of physics. So if you said rotate the block, it said, I don't know that word. That's all it said. It had no notion of rotation or anything. But as long as you stayed in its narrow domain, it worked. And that, again, is another general lesson, which is programs that are very careful about delimiting a domain can be much more successful than ones that try to deal with things in a more open-ended way. I wrote this up. This is actually the first version of the book about it, which was published by Edinburgh Press before it got picked up by regular publishers. Okay, quiz. Who's that? My hair was once not white. And who's that, right, is Marvin Minsky. who was the director of the Artificial Intelligence Lab at MIT, where this work was done, they had a series of different projects, different students working on things like the actual vision programs, the seed blocks, and the actual manipulation programs to move them around. So I didn't do any of that. I mean, I had this artificial representation, but it was motivated by this whole thrust of building intelligence. This is one of Marvin's ideas for a robot arm. Why should you make it have one elbow and one wrist and so on? That's just historically the way we happen to evolve. So what if you had all of these multi-degree of freedom joints and so on? He was actually, to go back, a technical advisor for the movie 2001. If you look at how the robot arms and stuff work there, he was one of the advisors on that. Okay, what's the question? What is Watson? Right. So this is in the forum. Notice the latest version of sort of AI kind of language stuff. Watson was able to answer questions about trivia, simple things that can be pieced together. Again, I'm not going to go into great detail, except to point out that it's a certain domain of questioning, kind of question, that doesn't require putting things together in a deep way. It just requires finding facts at a more surface level. And computers are great at handling huge amounts of stuff at a surface level. So, linguistics. Here's the third view. Another test. Who's this guy? He is known in the HCI world as Bubblehead. And Bubblehead was the creation of Moran, Card, and Newell. Moran is just recently retired from IBM here. Card is still actually retired from Park, but at Stanford. And this was a view of human cognition, which said, we are very much like a computer processor, just different parameters and different kinds of buses and stores and stuff. So these diagrams here are the kinds of the particular hypothesized, it says perceptual processor, cognitive processor, motor processor, auditory image store, visual image store. Right, if you were doing a block diagram for a computer you're building, that would look like that. And these numbers here are about things like throughput. Right, so the whole movement to see people in this way was started in the 50s, actually. And the experiment, which sort of is the flag wave for this, always done, is George Miller's experiment. Okay, just in case some of you don't know it, we'll do it right here. Repeat after me. 3042. 961. 5823461795. Okay, now the striking thing about that experiment is that if you take a large population of people and you look at how far you can go before they can't remember it that way, you do what's called your short-term memory, you don't get this kind of gradual slope. You get this sharp knee. The knee is at 7 plus or minus 2, right? His article was called the magic number 7 plus or minus 2. So almost everybody can get you up to 5, and almost nobody, and it's an almost. There are some people who have this ability and can do much, much more, but almost everybody can't go past 9. And somewhere between 5 and 9, it cuts out. Why? Think about what your model is of how your memory works. Why would you have that funny cutoff? And of course, from a computer point of view, it's pretty simple. You got a buffer, and you overflow the buffer if you get more than it goes in it, right? So there was a whole world of potentially computer-based models. I don't mean in the sense the computer ran the model, but it was a model based on the way computers are built, for looking at people as cognitive processors. And that was, in fact, the Newell and Simon wrote a book called Human Information Processing. Okay, so it includes things like processing of this kind and decision making. So chess, for example, was a big study they did about how people make decisions in making chess moves. This is Al Newell, Herb Simon, who were sort of the real creators of that view. Herb Simon is the only computer scientist who's ever gotten a Nobel Prize. And you may ask, how is that? Because they don't have a Nobel Prize. They have a Turing Award, but no Nobel Prize. He got it in economics, and it was for economic theories which later developed into his theories of cognition. Right? There's a direct line from those theories into viewing a person as a cognitive processor. So the whole branch of cognitive psychology, which really grew out of that view, was how do we understand people in terms of cognitive processing? This was really the origin of the HCI field. Go back to the earliest, conferences and books and so on in the mid-'80s. This was the dominant paradigm. How do we understand people as cognitive processors so that when we build text editors or whatever it is, they work well with people? So it's in some sense a conversion of that old Dreyfus thing. If you're building something that's going to do this, you have to worry about the arm length. If you're going to build an interface on a screen, you have to worry about their memory size, things like that. At the same time, there was this world of Engelbart's, which I mentioned earlier. This is Engelbart's augment group at SRI. This was back before Silicon Valley had developed its current dress code. All engineers wore white shirts and ties. And they were all guys, of course. His idea was that a computer wasn't just something to interact with. It was something that took account of people's interaction in an organization. It said a person is not just doing something, they're connecting. They're doing things with other people. So we need to augment that ability, that was one of his favorite words about it, by creating systems that let them communicate, let them jointly edit, let them do all the things which, again, if you look at this is what he wrote about those things, this is back in the 60s, it's really about the net of today. We have much more sophisticated in detail ways of doing them, but what we think of as social networking and email and all that kind of stuff, you can see the origins back in what he did, or he and other people, of course. One of the things that I was actually involved in was looking at, in specific, at how people operate in organizations to get things done by mutual understanding of what expectations you could have from other people. They're called commitments. So take a simple case. If I say I'll get you that report by tomorrow, you have reason to assume either it'll get there or you'll get a message from me saying why not or whatever. How do you build that into the computer systems? So computer systems that were based on that kind of view, let me go to the slide where I've added the decoration. You've got the pattern by now, right? That you say, you got to work at an organization, and there's a whole world of management and business theory and issues and questions that can be applied to the question of how do you build computers so you can interact with them. It's not just a matter of can you hit the button, but what does this person over there get when you hit this button over here, and why, and what do they understand it? So it's moving to a more social viewpoint. All right, continuing in our historical quest, who recognizes this page of text? I mean, it's Michelangelo. Preserving Stone's book on Michelangelo, but what do you notice about it that is really strange? It was generated by a computer. Of course, it's not really strange. It's in a font. All right, so this was one of the first pages done by what was called the Research Character Generator. Were done by Alan Kay and Chuck Thacker and Butler Lamson, a bunch of people at Xerox PARC. And the idea was that just because something was put out by a computer, it didn't have to be computer text. That the full range of ways that we use for communicating information should be available to a computer. This actually predates all this stuff about Alto and Star. It's the same group, and they started off by saying we can put things into characters. So what this is about is thinking of the computer and person in terms of conveying information. And I was part of a project called the Stanford Digital Libraries Project. This is back in quite a bit later than that Research Generator. I'm jumping ahead, but and the idea was there's all sorts of information online now. And of course, back in those days, it wasn't the web. It was things like internet libraries and Lexis and Nexus and all those kinds of things. There were, how many of you ever heard of Z3950? A couple old timers, right? Z3950 was a protocol for exchanging meta information about documents. And things like Gopher and Waze. There's a whole menagerie of stuff out there trying to grapple with this idea of how do you take information that's in a lot of pockets and get to it in a useful way. This is after the ARPANET had been created. So the raw networking capacities, like Telnet, were there. And this is done just after HTTP had come out, right? So there were protocols. but how do you pull them all together into a unified way? And we had a couple of students in the group who said, oh, we're going to go to the web and we're simply going to take everything. This is actually the Google homepage before it was a company, right? You'll see it was google.stanford.edu, right, still. And they had this idea which, well, they followed an idea. They were not the first to have it, which is you could automatically index the stuff that was out there. You didn't need a lot of organization. You didn't need a lot of meta information. You didn't need all the junk that we in the sort of library-influenced vein had picked up. Rather, you just do dumb text search, but you do it at such a scale that you can actually find good stuff. The switch from focusing on the clear structure to focusing on scale, I think, happened in a lot of domains, and happened certainly with Google and search engines back in the day. And of course, they had a lot more ideas than that, but it was really a switch. But it's part of a more general view which says people are information seekers. I use the word informavore here. Again, going back to Xerox PARC, Peter Paroli and Stu Card at PARC had this whole theory they call information foraging. And it's about how do you go and find the kinds of information that are relevant. So there's a whole world, again, of information science and design. A couple of more dimensions. This is a gathering. Some of you may recognize this is your photo by John Coate. Anybody know who John Coate was? He was one of the first people on the WELL. You know what the WELL was? Whole Earth Electronic Link, which was the predecessor of social computing, social networking. It was a simple text-based bulletin board type forum that developed a community around it. People could type things in, they could comment on other things, they could, things that we do now with blogs and with Facebook and all that. Again, much more primitive, but still in that same vein of what I care about is not getting jobs done, it's communicating with others, having intellectual discussions, it's having gossip, it's whatever it is that goes on. But it's not just email one person to one person, it's part of a community. The WELL, what was interesting about the WELL, it was the first online community. But it also had non-online. This is the lesson, actually, for online communities. Right, so this is actually their first annual chili cook-off, where all the people who were getting to know each other online got together to eat chili together. It's an interesting question today, sort of when a social network looks like this, I'm not going to talk about that in any detail, what it means to get together as a community. Now, that raises another question. I actually put this up when I first made this slide set. I think the numbers of followers here he only had 32,000 followers there, right? I mean, it's gone to a million or something like that. That notion of people socially getting together with each other has morphed and extended in various ways. But they're all around thinking of the user, thinking of the person, not as someone using a computer, but as someone interacting with the community, interacting with other people, where the computer becomes a vehicle for that. And if you go to the CHI conference now, the main HCI conference, you see a tremendous number of papers which are really motivated by sociology and anthropology, not by cognitive psychology. There's still a few cognitive psychology papers around, but not that many. A lot looking at how do people, what kind of social behavior does the interaction either create, make possible, make hard, make easy, and why, and how do people follow that? There's a whole set of issues which look at a human being from this point of view as their social thing. Now, I want to generalize that out a little and talk about meaning. And meaning here, I don't mean in the Sherdlu sense of what does it mean to, say, pick up a big red block, but in the human sense. What gives people a sense of meaning in what they do? I'm going to give a quick sidetrack story because it's an interesting case lesson. This is actually from a friend of mine named Michael Barry, who has a design company. And he was asked by Kimberly Clark to do a new update on the design of their diapers. And what he said is Kimberly Clark thought of diapers as waste disposal bandages. And the engineers were all making them less leaky and more comfortable and all those things. He went out and he spent a lot of time talking to parents. He may have also talked to the kids, but in this case, the users really are the parents, about what does it mean. And what he realized is that diapers have huge emotional meaning about maturity, age, development, all the things that parents worry about in their kids. So he came up with the idea of pull-ups. Now, from a pure engineering point of view, they are worse than other diapers. Right? They're less comfortable and they don't hold stuff in as well. But as you will notice here from the subtlety of the advertising people, they convey an image, which is I'm grown up. I'm wearing pull-ups now. I'm not a baby anymore. And that difference in seeing the meaning of a diaper, my first underwear, right, is on the package. Right? People who sell things are not subtle about pulling these strings, right? So what it says is that you realize that the meaning of a diaper wasn't how well did it hold pee. Right? The meaning had to do with what does it mean to be a baby, what does it mean to be an older child, what does it mean to be a good parent of a child, and that was the domain you needed to think about if you were a diaper designer, not the domain of waste disposal bandages. And the same is true in interaction design, right? It's not, a person is a source, right? They collectively, socially come up with what is meaningful to them, and dealing with that is the key to understanding what will work and what won't work and why. Which is to say, why do we have a science of HCI? Why do we have a discipline? It's trying to understand that. So what do people do? Identity is one angle. I'm sure a lot of you have seen this cartoon. It's probably one of the most famous cartoons ever. He says, on the internet, nobody knows you're a dog. All right? The idea being that your identity, because we all care a lot about our personal identity, isn't coupled directly to what your identity on the internet. There's this decoupling which comes from sitting at a keyboard and typing at it. Right? Notice that this has evolved in lots of interesting ways over time, but this basic question of personal identity is a key part of what it means to be human. This is an interesting example. These are both two imaginary people. This is part of a teaching system where the kid who's learning interacts with another kid, who's, of course, computer generated. I've forgotten her name. Somebody know? Right. She is a major rock star in Japan. The only problem is she doesn't exist in the physical world. Right? But she sings songs and she has websites and she does all sorts of stuff, right? So this blurring of where your personal identity goes online is a major area for design. Second is your social identity. So how many of you have a blog, meaning one that you write? A few, yeah, half a dozen, right? Why do you have a blog? Why don't you just write those things for yourself? Social identity, right? That is, you want other people, and they might be the whole world, it might be your friends, whoever it is, to read those and have some understanding of you and who you are and what you care about and how smart you are because they've read your blog. So this happens to be my daughter's blog. She's a rabbi and writes about kosher baking. But it's her identity. I mean, it's really interesting to talk to her about, what she does late at night when the kids go to bed and stuff. It matters who reads it, who's in it, what are the other people who have blogs. There's a list here of other people and so on and so on. Right? So you're creating, if you say what makes blogging important, if you just say it's information, you lose that. It's about groups, social identity, who you're talking to. So blogs, I'm using the word fame and fortune here in a kind of dismissive way, but it's not. It's, getting known and sometimes getting money for it. Another dimension that gives people meaning, as you may notice, I've mentioned my grandsons, my daughter, and so on, is family. So this is an interesting project. It's a company which was started by a former student of ours. He actually worked on the iRoom you saw a while back, which lets a child and a distant, loving person, grandparents are the big market, of course, read a book together. So it's got enough video that you can see each other. When you point to something in the book, this shadow hand points to it on the other person's screen. Very simple from a technological point of view, nothing great, but what it does is create a context where you feel that you're getting meaning from being part of this connection to your family. And a huge amount of use of computing today goes into that kind of thing. Community is another thing. Part of your meaning is doing things for your community. This is just my own particular long-term case. I was, back when I had hair that color, one of the founders of something called Computer Professionals for Social Responsibility. It was in the era when we were really worried that there was going to be a nuclear war, either intentional or even more likely inadvertent. Reagan, saber rattling, those of you who know your American political history. And a whole bunch of groups got started in all different areas. There were physicians for social responsibility, educators for social responsibility, landscapers for social responsibility. And the issue was, could your particular professional skill be relevant to some way helping with this problem? And the obvious point with computing was that a huge number of the systems involved in nuclear weapons are computing systems. And they have to be reliable for the obvious reasons. You don't want them to make mistakes, right, and so on. So the slogan that we had, technology is driving the future. It's up to us to do the steering. Notice it's very different from, say, Kevin Kelly's. What's Kevin Kelly's book? What technology wants. Right? We're saying technology does. It doesn't want. We want. We drive. Right? It's going to get us there, wherever there is, depending on how well we're able to steer it. Another area, just as I say, this is sort of a personal run through. The last few years, I've been involved in something called the Program on Liberation Technology at Stanford, which deals with the use of computers in mostly developing world areas on things like health, education, and so on. It's another talk. I'll be glad to talk more in the question period. I see I'm running close to the end time. Okay, so one last element. I have always, since we started the talk series that Ted has talked in 7 times, is not called the Human-Computer Interaction Seminar, although that's its official name. It's called the Seminar on People, Computers, and Design. What's design? So this is a book I referred to earlier, Henry Dreyfuss. This is back in the 30s. Dreyfuss wrote a book called Designing. He started in the 30s. This book is in the 50s. A book called Designing for People. Notice that the two things. Designing is an act. Okay, we're talking about the designs. We're talking about designing. And people are what's at stake. He actually was a stage lighting designer, and then became an industrial designer and did a tremendous amount of industrial design. Did things like the whole experience on the railway trains from Chicago to New York, including designing the cars, designing the way you got on and off of them, and all that kind of stuff. I edited a book a few years ago called Bringing Design to Software. We had a conference, got together people from all different kinds of design, urban design and mechanical design and computer design, to look at what is common about that. The problem of understanding how to go about building things so that they work for people. Last few years, I've been engaged in something called the D School, D for Design, at Stanford, which was created by David Kelly primarily, a number of us working with him, but he was the central person. A lot of you may know him. He was the founder of IDEO, a design firm which has done thousands of products over the years, many of them in Silicon Valley. And what we do there is a series of courses where you have students working together in interdisciplinary teams. So we talk about T-shaped students. The idea is Stanford, to pick any university, tends to be really good at giving you depth. We take a graduate student who's in sociology. They really know sociology, right? And that's how the training goes, and they learn it. But what they aren't good at is understanding how what they do fits in with what everybody else does to get something really useful and that works for people. So the courses are all oriented around getting small interdisciplinary groups. They have to have a mixture of these with engineering, which I guess is the base. It doesn't come in here, to work on real-world projects and come up with new ideas for them. And again, I mean, I can give a whole D-School talk, but it's been really, for me, really interesting to move away from the focus on just the interaction to this larger picture of design. Let me skip over a couple. This is the course. Well, I'll just go back one. I do a course with Josh Cohen, who's here, where we do design projects in Nairobi, in Kenya. And we partner with, which you see this group here. It's got our students and then the students from the University of Nairobi that we partner with. Part of the whole philosophy is design means really understanding people directly, not just reading about them in books. So you want to work with people who actually have that connection. Okay, I'm at the time limit, and I'm just going to say quickly what this is. I got, at the end of this, remember I said I got it for an award about being a wise old researcher. When you get a lifetime award, it basically means, well, your lifetime is over. Now it's time for the award, right? So I got into sort of preachy mode. But this is for the CHI conference, and the obvious point about the CHI conference is it's many things. So is there room for research on new computer technologies? Of course, right? We're coming up with the new things all the time, whether it's bendable optical screens or whether it's brainwave reading or whatever it is. The field is going to continue to be engaged in coming up with new technologies. The human sciences, as I said, you go to CHI today, you find lots of people doing research on how do people interact in groups, how do they interact socially, all those questions. Interaction, there's still a lot of research on the specifics of mechanisms. So Ted was telling me about a paper that he'd worked on about how do you display two different hierarchies at once and compare them and contrast them and so on. Right, just how do you get interactions that make sense for people on a screen. And then design. Design research is actually a very complicated question. It's just how do those two intermeet? Because research tends to be focus in on some specific question, and design tends to be make something work as a whole. So one is sort of a broadening view, and one is a sort of focusing view. And it's often hard to bring those together. So I turned it around and said the question really is thinking of your own research from a design perspective. Not how does the system, but how does what I'm doing fit into this larger picture of design. And I think I'm going to leave it at that. I have a couple of more explanatory slides, but leave it if you have any time for questions. Yeah. All righty here. Just run back a minute. I sort of jumped over this slide while I was trying to hurry a bit, but now I'm wasting time looking for it, of course. It's true with computers. You waste time on things that you think you're saving time with. Almost there. So, in answer to your question, this is Fernando Flores. This is the book that we wrote together called Understanding Computer and Cognition. Side note is that we are about to start work on a new book together. That's my next project. And what he did, and I'll tell you what the two books are because they're sort of related. He brought in experience with both philosophy and management. He was actually very high up in the government of Chile before the coup that got rid of killed Salvador Allende. He was a political prisoner for 3 years, and then ended up coming to Stanford. We started working together. So he had that experience before he was, during the part when he was governing. He had developed one of the first interesting sort of cybernetic systems. He worked with a cybernetician named Stafford Beer, the question was, how do you optimize better a whole economy like the country of Chile? And they had this very sort of straightforward, simple, I won't try to explain it. There's a book about it, which you can look up. If you look up Stafford Beer on the web, you'll find it. anyway, he had, and also read a bunch of philosophy from people like Hubert Dreyfus. That's not Henry Dreyfus, who I referred to earlier. I think unrelated. But who had looked at phenomenology, people like Heidegger and Merleau-Ponty and so on, these very European things, and John Searle, who had studied how people get things done by interacting in language. Right? Speech Acts is his famous book. And I had this experience in computing, and let's go back to Sherdlu, you remember the blocks, and language. And these two sort of came together, and we ended up writing a book which had the philosophical background, and then a whole discussion of artificial intelligence and where it was going and why certain approaches were not working. And I'm not going to go into all of that, but it was, for me, a real interest. It was interesting because he came into this with a set of concerns. He knew nothing about AI and programming. And I knew very little about the stuff he knew about. And there was what I always call a resonance. Even though we were talking about different things, there seemed to be a similarity in the overall view, which had to do with the difference between explicit and implicit knowledge. Put it at that level. It is what you saw in Sherdlu was all explicit knowledge. Anything you knew about blocks was there because I put a rule in which said, here's about blocks. And what goes on in people-use language is much less explicit than that in important substantive ways, not just small ways. And he says the same for things like management. So that's how we got to writing this. The one we're going to be writing now is bringing in, again, philosophical background. We've got some new, he's dragging me into reading some new philosophers, like Sloterdijk and Oakeshott, and people I'd never heard of. And we're looking at computing today, which is not about AI, but social computing. So what does all this philosophical background have to say for things like, things I was talking about, online identity, social identity, all those kinds of questions, that whole subject. So that's, I don't know, I could answer your question, take hours on it, but that's a quick.
I'm K.R. Smurthy, I'm a big data expert. Like you were talking about people, human being, human word. What about the society word when you look at the big data, which abstracts the society's understanding, society's thinking, society's perspectives, society's goals? And that you didn't cover, I know, because of the time.
Well, so there's two different dimensions here. There's personal versus social, and there is thinking in terms of big data versus thinking in terms of interaction. So people who do what's called the quantified self want big data about their body, right? They could have every cell clicking off sensors. They would have big data. It's just themselves. So big data is sort of a orientation, a perspective, which could be applied to one individual, could be applied to societies, could be applied to anything. And it's basically a philosophy of quantification. So the things that matter are things that you can actually put into data, which moves it away from, of course, the whole humanities in those areas. And the notion that by aggregating big amounts of data, you can come up with patterns which you wouldn't have seen by looking explicitly. So, and I think that there's no question, there are many fields in which that's relevant. Let's go back. Google. Why does Google work? Because it's got trillions of websites. And when it does the calculation to see what's relevant, it's making use of that. Google Language Translate is a really good example, right? That is, when I was doing Sherdlu back in those days, people who were doing language translation said you have to have a thing that analyzes, that understands, that gets a full parse tree, that figures out the logic, and then and so on, so on, so on. Google Translate doesn't do any of that. It just looks through trillions of words of stuff for stuff that's sort of like what you have, and then looks for corresponding words sort of like that in the other language, which on the face of it seems like really hopeless. But it turns out, this is the big data philosophy, that when you get millions of utterances, it averages out right? I think there are some phenomena for which that works well. I think there are some for which it will give either useless or even misleading results. And I think what's going to happen over the next decades, I mean, we're still in the wave, as with any business thing. Anybody remember the rise of expert systems? Okay, my colleague Ed Feigenbaum, who was also at CMU. I should have mentioned when I went to Newell and all those guys, that was CMU. Anyway, Feigenbaum was from CMU originally. And his view was the big deal for companies, and they better get on it fast or they were going to be left behind, was to build expert systems. Now, it doesn't mean expert systems, the fact that that was completely wrong doesn't mean that expert systems are useless. It just means they only work for certain kinds of things and they don't answer all the questions. And I think we're exactly in that phase for big data. Everybody who wants to get money on Sand Hill Road says big data. But it's only going to work for certain things well, and we'll learn.
We're getting a little late. I want to just see if I could get one student possibly to ask a question. So you guys are kind of, you know, my hope of the future. Can one of
So
you please?
I can do it for you. Will this be on the exam? Oh.
Does anyone have a question that they can think of to ask? You're still a student after all these years.
Yeah. Well, my question relates to your T-shaped diagram and some of the questions. What is a collaborative research philosophy? In other words, what kind of people do you look for when you're trying to start something new?
Yep, that's a great question. So I think, I mean, the bottom line is, of course, differing perspectives. So it's not just differing training and so on, but you really come at problems from an angle. You know, one of Alan Kay's famous sayings, which I will get wrong, was a different point of view is worth 20 points of IQ, right? And so I think then the question is, what are the things that are relevant? Somebody comes in and says, I really know a lot about French literature. How relevant is that? The ones that are obvious, we talk about, actually, we have a diagram we always use. There are 3 overlapping circles, which we call desirability, feasibility, and viability. So desirability is the human side. Is this something you want to design and people want to use and so on? Feasibility says, technically, is this something that actually can be done? So you've got to have somebody who's, you know, really knows the engineering, whatever it is, whether it's